In the last class, we have seen a few examples of fuzzy sets. I hope it is now clear what is fuzzy set, how it is defined, and as you know that fuzzy set is actually ordered pair, where first element is the x on the x axis and the other element is its membership function or membership degree. Okay. So, today we will do few things. First is what is convex fuzzy set, then we will do subset of fuzzy set, next cardinality of fuzzy set, and lastly we will do today few standard operation of fuzzy set. So, in a nutshell we will do these four things: convex fuzzy set, subset of fuzzy set, cardinality of fuzzy set, and standard operation of fuzzy sets. And I hope you know all these with respect to your standard set theory, that is crisp set. Okay. So, let us do one by one. So, let us start with convex fuzzy set. Okay. What is convex fuzzy set? We have already defined about convex crisp set, no? And you know also what is convex set, okay, for the crisp set theory. So, that means if I take 2 points in a set and if I join those 2 points by straight line, then those all points should lie in that set. Okay. So, in terms of mathematical expression, I can write, if for crisp set we know what is a convex crisp set. If I have 2 elements or points in a crisp set S, okay, then we take any parameter lambda such that we will write like this: lambda x1 plus 1 minus lambda x2, and this should belong to also in S, where x1 or x2 in x1 and x2 are in S. This is the definition actually for convex set for crisp set. Okay. So, then we said this is convex, where lambda belongs to. Okay. So, this we know. Now, from here let us derive or let us define what is the convexity for a fuzzy set. Okay. So, here it is same actually, a little bit extension. So, here this x1 and x2 belongs to the fuzzy set, suppose now A bar or S bar. So, then we should have, see, whenever we are talking about fuzzy set, you think about the membership function. Main is the membership function, because along x axis you have the elements, no problem, but the membership function is the main difference here. So, let us have this membership function of this, that means mu of A bar is your fuzzy set of this lambda x1 plus 1 minus lambda x2. That I can find if your x1 and x2 belongs to A bar in fuzzy set, that I can then its membership function. Okay. So, then this should be greater than or equal to minimum of membership function of x1 on the same set and x2, where this x1 x2 belongs to the fuzzy set A bar, and remember this mu A bar x1 and mu A bar x2 are the membership functions or membership levels, grades of x1 and x2 in A bar. That means, if you have given 2 points x1 and x2, take these combinations, and remember here again lambda belongs to 0 1. Okay. You take for any lambda in 0 1 closed set, take this convex combination lambda x1 plus 1 minus lambda x2, find its membership function on the set A bar, and then separately membership functions of x1 and x2 in A bar. If this is greater than or equal to minimum of this, then we say that this fuzzy set A bar is convex. Okay. Now, let us take geometrically, then see geometrically what is happening, then it will be more clear. Okay. This is the definition. Okay. Clear? Now, let us come to the geometrically how it is happening. Remember this. So, for convexity of a fuzzy set, suppose I have a fuzzy set like this. So, x is this side and this is your membership function mu. Okay. Now, suppose your fuzzy set is like this. Okay. We had this type of shape earlier also, we had given examples. Suppose I take 2 points x1 and maybe here x2. Okay. So, I have to see its membership function. So, membership function will be nothing but draw a vertical line and remember this is 0 and this is, if it is normalized, this is 1. Okay. This all I have defined, what is normalized, etc. Okay. The height should be 1, etc. Okay. So, now it is varying from 0 to 1. So, for this x1 and this is a bar, this is the fuzzy set. So, its membership function I can define as mu a bar x1, whatever value is there from here to here. Okay. Now, take this for x2. So, this is your, this point is mu a bar x2. Okay. Now, let us take any other point t which is actually lambda x1 plus 1 minus lambda x2. For particular lambda in 0 1, I can find this t. Okay. So, and it will be in between this x1 and x2 I am taking. So, it will be in between this. Okay. Now, take vertical line here and draw this horizontal line. So, this is your mu a bar what t. Okay. Now, you see the condition that I had given, mu a bar t should be greater than equal to minimum of mu a bar x1 and mu a bar x2, and this is satisfying because see minimum value of lambda is 0 and maximum value of lambda is 1. Let us put lambda equal to 0 here, lambda equal to 0. So, what we will get x2, okay, x2. So, what will be there, mu a bar x2 which is equal to minimum of this, equality is also there. If I put x equal to lambda equal to 1, so lambda equal to 1 means this term will be 0, we will get what, x1, understanding, x1. So, we will get what, mu a bar x1 and minimum of this 1 will be there, mu a bar x1. So, this condition is satisfying. So, in between point also, because it is convex, you can take any point. Okay. If it is satisfying this, then it is a convex set, convex fuzzy set. Okay. So, let us take another example which is not convex geometrically, then it will be more clear. Okay. Now, let us take a shape like this. Suppose it is a, I tell that this is a fuzzy set, suppose it is a fuzzy set. Now, let us see whether it is a convex or not. Okay. So, let us take here a point x1, here a point x2. Okay. So, I draw a line, again here 1 etc. there 0 1, this side is mu, membership value, this is x. Now, this will be your mu a bar x1, mu a bar x1. Okay. And if I take x2, so this will be your mu a bar x2. Okay. I will take in between any point, I can take this point t or not t. So, you see now this is your mu a bar t. Now, you see clearly that it will not satisfy this, it will not satisfy this. So, this I cannot say that this is a convex fuzzy set. So, now geometrically also I hope you are clear what is convex fuzzy set, what is non-convex. Okay. Clear? Now, next come to the next one that I wrote. What was that? That was subset of set, so fuzzy set. Okay, I am erasing this. So, subset same, whatever you know in CRISP, it is just the extension. So, before subset I will just define one equivalent set or equal set you have read in CRISP set theory. Okay. Equivalent set or equivalent fuzzy set. equivalent fuzzy set. So, if it is equivalent, you should have two fuzzy sets. Suppose I have two fuzzy set A bar and B bar. I want to see whether A bar and B bar are equivalent or not. So, naturally I am telling, whenever I am talking about fuzzy set, you should see about the membership functions. So, simple way, equivalent means the membership function of fuzzy set A and membership function of fuzzy set B should be same for particular x. So, definition is, if A bar and B bar are, let A bar and B bar are two fuzzy sets, then those are equivalent if we have membership function of x for A bar is equal to membership function of x for all x belongs to your capital X in that A or B. Okay. Same membership function, if it is equal, then we say that this is equivalent. So, geometrically also I can see, means suppose this is 1, this is 1, 0, 0. So, if I have a support like this, so same shape, same. Okay. So, these are two equivalent fuzzy set. Okay. Now comes subset of a fuzzy set, not 2, that Roman 2, subset of a fuzzy set. Okay. So, a fuzzy set A bar is said to be a subset of a fuzzy set B bar if membership function of the first one, that means A, is less than or equal to membership function of fuzzy set B bar. Okay. So, A bar is a fuzzy subset of B bar if we have mu A bar, then mu A bar x less than or equal to mu B bar x, and again for all x belongs to x. Okay. So, if you can find this, then A bar is a subset of B. Okay. From here we can again define proper subset. We define for crisp set theory proper subset. Here also you can have proper subset, proper subset. So, I can write this as A bar subset of B bar. Okay. Okay. If it is subset, this is just notation that you know from crisp set theory. A bar subset of B bar. Now, proper subset, what should be the condition? Here this equality will not be there, that means strictly less than that mu B bar x. Okay. So, that means proper subset. So, here the membership function for A bar should be strictly less than, okay, mu B bar x for all x belongs to it. Okay. Similarly, geometrically I can represent this like this. Suppose I have this x mu, I have B bar, suppose this, and if I have A bar like this, so all the membership functions will be for A bar will be less than equal to B bar. Okay. So, I can say that A bar is a proper subset of B bar. Okay. Now comes to your cardinality. You know, in crisp set theory, cardinality is what? Number of elements in that set. Okay. So, for cardinality we have three types of cardinality in fuzzy set. Okay. Three types of cardinality. So, that you will see very easy again. So, cardinality. So, here we have three types of cardinality. First one is known as scalar cardinality. Second is relative cardinality, and third one is fuzzy cardinality. Okay. Now scalar cardinality, this is very easy. If you have a fuzzy set A bar, so there you have for different elements different membership functions. You add those membership functions, that is your scalar cardinality. Okay? In crisp set theory, you are counting here for different x, you have different membership functions. So, this is scalar cardinality for A bar, suppose A bar is a fuzzy set, okay, we denote by this. Cardinality of A bar, scalar cardinality is defined as summation mu A bar x, x belongs to x, simple. Okay. Suppose I take that example I did last day, that young, old, etc. So, let us find for that, so it will be more clear. Suppose I take senior, senior was fuzzy set, there we have infant, senior, adult, okay, like that. So, senior fuzzy set. So, for senior, this was a fuzzy set, its cardinality, scalar cardinality, what are the their membership functions we have? 0.1 we have, what were the, tell me, 0.1, 0.3, 0.9, 1 and 1, 0.1, 1, another one, okay, another one, no 0.1, okay. Okay. So, 0.3 plus 0.9 plus 1 plus 1. So, what is that? 3 point. So, this is the cardinality for this senior fuzzy set. Very easy. Just add the membership functions. Okay. Now, come to the relative cardinality. Relative, as we do for relative error. How you find relative error? Relative error is true minus exact by true. So, like that there should be some division, okay, relatively with respect to something. So, here this is defined as, so I denote by this for relative, okay, this is your, for this double line is for relative. Relative cardinality is defined as scalar cardinality of A bar divided by total, means total x, and this x is actually crisp. If you see the previous example, there x I had written the age, I think it was starting from 5 to 85 I think. So, how many? 5, 15, how many? I think 9 or 10, 9 should be there, 9. So, for this example senior, for senior what is the relative cardinality? It will be 3.2 divided by 9, whatever you get, that is your relative cardinality. It is also very easy, no? So, these two are very easy, this is also very easy, fuzzy cardinality. So, let us, we do not have a space here, I will define here, okay. I am erasing these two. So, see here this fuzzy cardinality, how we define. So, take any set, suppose I start with that example. Suppose I take senior, okay, that in the previous example that senior was a fuzzy set. So, if you go to the senior, there are different alpha values, you are having what, tell me again, 0.2, 0.3, 0.9, 1, 1, okay. So, if I take this, so for 0.3 now you know also alpha cut I have already defined. So, if I want to find senior at 0.3 alpha cut, so you are having crisp set, if you remember, senior at 0.3. So, let us write like this, alpha and what is alpha, and here you are understanding A alpha bar, you remember when I write A alpha bar, this is a crisp set or not, because when I take this alpha level set, it turns out to be crisp set corresponding to this alpha, remember. So, this is your crisp cardinality for that alpha level set. So, if I take alpha equal to 0.3, so in A alpha bar how many edges are there, means how many elements will be there, means it is greater than or equal to 0.3, 4. Sure, you are seeing your examples previous days, you see their number of that elements will be 4 or not. Okay. Similarly, if I go for 0.9, 0.9 means greater than or equal to 0.9, what are the edges that you will 3? If I go to 1, how many? 2. That means first you take all the alpha values for any set. Suppose I go to adult, if I want to find cardinality, fuzzy cardinality for, this is fuzzy cardinality, remember, okay, this is okay. So, for fuzzy cardinality of senior also you have different membership values, I think 0.2, 0.3, it is starting from 0.2 or 0.1, okay. So, whatever. So, again you see for 0.2 how many are there, 0.3 how many are there. So, that means here only 3 elements and corresponding to this 3, these are crisp cardinality of these sets. So, now I write this like this again, senior, this cardinality, fuzzy cardinality I can write is as F, okay. This is just notation, fuzzy cardinality, because it is fuzzy cardinality, so I should have ordered pair. Fuzzy cardinality I should have ordered pair. So, for this element 4 I have the membership function 0.3, for 3 I have 0.9 and 2 I have 1. You are understanding? It is very easy. That means you should have the connections of all these definitions, you should remember, okay. So, now in general I can write cardinality of A bar as alpha and mu A bar, not A bar alpha or not, where this alpha belongs to 0 1, mu A bar alpha. No, this is not. This is what? Cardinality. So, I have to write A bar alpha and here alpha and for all alpha. Ordered pair. No, that I wrote ordered pair, but I wrote wrongly actually. First is your cardinality number 4, 3, how many are there? So, A bar alpha, that cardinality, and for what alpha? That is why for all alpha, whatever alpha you have. So, those are the, and alpha belongs to 0 1. Okay? Clear? So, we had cardinality, 3 types of cardinality, scalar cardinality, then relative cardinality and fuzzy cardinality, very simple. Okay. Now comes to the important thing, that is standard operation. Standard operation of fuzzy set. No, last one. Standard operation of fuzzy set. First one, let us have complement. We know in classical set theory, complement. If you have A set, complement. If I have this X, this A, so complement is this in crisp set theory, outside this. Okay. Here, see, I have a fuzzy set A bar, I have to find a complement of this. Okay. We define this complement as, define means denote by A bar C. This is your complement. Okay. And for A bar, you should have, for each X, you should have a membership function. I define this as mu A bar X. A bar is your fuzzy set. For this, you will have mu A bar complement X, but what is this? 1 minus mu x, because your value is from 0 to 1 including 0 and 1 closed set. Okay. So, here we define this mu a bar x as 1 minus mu a bar x. So, if any for any element x 0.8 is the membership function, so for complement it will be 0.2. If it is 0, that means it is negation, okay, whatever there 1 minus that. So, that is your complement. Okay. Complement is very important, I will go little bit detail after this other two standard operation. Okay. So, complement you understood, whatever fuzzy set is there. So, x, so for this I can write this fuzzy set as x mu a bar x. So, for complement of this set, complement I have x mu a bar complement x means 1 minus mu a bar x. Okay. Okay. So, let us now come to the next operation, that is called union. Okay. Union of two fuzzy sets. Union. So, if we have two fuzzy sets A bar and B bar, okay, if we have two fuzzy sets A bar and B bar, A bar and B bar are two fuzzy sets, I want to find union of that two fuzzy sets. It is again very simple. So, I write another set C bar, fuzzy set C bar, and I write like this A bar union B bar. This is okay, mathematically it will be A bar union B bar, but main problem is with the membership function. I have to write the membership function of this. Okay. Membership function of this mu C bar x should be maximum of simple mu A bar x and mu bar x for all x belongs to x. Understanding? Very simple. You have two fuzzy sets A bar and B bar, you have membership functions for A bar and where this mu A bar x and mu B bar x are the membership functions for A bar and B bar respectively. Understood? Very simple, you have to take only maximum of these two values, whatever are there. Let us take an example from the same example. If I want to have adult and senior, let us take what is the union. So, I had adult as one fuzzy set and senior is another fuzzy set. Okay. So, what was there? So, whatever was there, I do not know, but what I have I am writing. Okay. So, let us take young and adult. Senior adult also you have to tell them adult, okay, because little bit values are changed here. Okay, so that is why I do not want to anyway. So, adult and senior. So, for adult we had adult as per my notes, it is 25, you can use your own, okay, whatever membership, because it is changing. I told no, it is person to person. I can say I am young, you can say no sir, you are old. Okay. So, that is again fuzzy, na? So, I feel I am young. So, that is why it is changing. Okay. So, you write on your own whatever you have written. Okay. So, it is 25, it is adult 25.9, then 35 1 and others are also 1, 45 1 like that. This is adult. And senior. Senior I am having here as 45. So, you can include your 0 also. In adult you can have 15 0, okay, 15 0, others also you can add, no problem. Okay. Previous also it was 0. Okay. So, here also I am taking 1 0. So, senior I start from 35 0, then 45.1, then 55.2, 65.6 and 75.1. Other value is also there, that is 1. Okay. Let us take union of adult and senior. Okay. So, adult is A, suppose senior is B, A bar or B bar, adult union senior. Tell me, here see 15. So, here what is the 0? 35 0, 15 here also 0. Okay. So, I can write this 15 0, or you can remove this, you may not include this, you start from maybe 25 also. So, let us take, no problem, 15, then 15, after 15 it is 25, 25, 25.9 and here it is 0 actually. So, I will take 0.9, 35 it is 1, okay, 45 1. So, you are understanding what is happening. Similarly, 55 1, like that. Very simple to find union, just take the, for different x, maximum of mu A bar and mu B bar. Okay. Suppose I want to find the complement of this, complement of adult.
25 0.1.
First 15 1, 15 1, 25.1, I forgot to take the example, but here I can take 25.1, 35 0, 45 0. If I want to take senior complement, that also you can write, take the complement of union, adult union complement, adult complement, union, senior complement. So, these games you can play very well if you have understood, okay, and it is very easy to understand. Okay. So, union is clear. Similarly, intersection, and intersection you are intelligent enough, that will be minimum. So, let us write for the sake of completeness. So, I can, okay, here something was that, the same example I can take, okay, 65 was 0 or 1, 65 was what, 0 point, sure, 75 1, okay. So, here if it is intersection, so I have the, okay, I am erasing this. So, definition will be intersection C bar is equal to A bar intersection B bar, where this C bar's membership function mu C bar x will be nothing but minimum of membership function of mu A bar x, mu B bar x for all x belong to x. Understanding? Very easy, where this mu A bar and mu B bar are the membership functions of A bar and B bar respectively. Okay. Now, find for these two fuzzy sets what is intersection, adult and senior. Okay. So, adult intersection senior. So, it will be 15 0, 25 0, because here 25 is not there, 25 0, 35, see 35 is there, both 35 0, 35 1. So, I have to take 0, minimum of that membership, 35 0, 45 45.1, 55, because here what was there, 55 was what, 1. So, it will be 55.2. So, now you can write like that, 55.2. So, similarly 65, I think both 65.6, there I think it is 0, 1. So, 65.6. So, like that you can complete. Okay? Means take the elements and take the minimum value of the membership functions from both the sets. Okay? So, similarly I can find A union B union C, A intersection B intersection C, very easy. First find A intersection B, then find intersection of C, union C. So, all the operations you can define very easily. Okay. Now, let us see geometrically what is happening, because that is very important. Okay. Let us first come to the union, and it is more or less that crisp set theory. If you see the geometrical. So, for union, if I have x and mu, and this is 0, this is 1. If I have suppose two sets like this fuzzy set, A bar and B bar. So, you take all those combinations, you will give all these, very simple. Crisp also we do like this, no problem. So, second is intersection. So, here x and mu 0 1, suppose I have same type of set fuzzy set A and B or A bar and B bar. So, intersection you will see what for this case, only this, as you do in crisp. Okay? These two are no problem. Now, come to the complement. Okay? Okay? Third is complement. Suppose I have a set fuzzy set A bar, okay, and I define this is normalized fuzzy set. So, I have this 1, is touching 1. So, this is a normalized fuzzy set, because I have the height as 1, I may not have 1. Okay. So, I want to find its complement. Suppose this fuzzy set I have from 2, 3, 4, 5, 6, these are x points. Okay. So, as per this fuzzy set, what is the membership function for 2? No, membership function for 2, 0, yes, sorry, 0. For 3, I can say that it is 0.5, more or less 0.5. Okay. For 4, 1, for 4 it is 1, for 5 I can say this is 0.5, and for 6 again it is 0. So, I have this fuzzy set, I can write for with respect to these elements A bar, because it should be ordered pair. So, 2, 0, 3, 0.5, then 4, 1, 5, 0.5 and 6, 0. This is your fuzzy set A bar. So, as per your definition, I can very well write A bar complement only subtracting from 1. Okay. Let us write first A bar complement as 2, 1, 3, 0.5, okay, then 4, 0, 5, 0.5, 6, 1. Is it correct as per our definition that we already defined? So, what is happening in the figure you see? Okay. Now, you see 2 is 1, means it should go here, this point should go here. Okay. 3 is 0.5, no problem. Okay. 4 is 0. You are understanding, that means your fuzzy set becoming like this. Okay. Now, 5 is 0.5, no problem. 6 is again 1. So, that means it is just upside down, and this is your fuzzy set complement. This is your A bar complement. Understanding? So, the difference you see, it is very easy to see here, but if you see the geometrically, this was your fuzzy set A bar and its complement is like this. Now, find, no space anyway, I want to find A bar intersection A bar complement. You know, in classical set theory, A intersection A complement is 5, and I told while I was defining that in fuzzy set it is not. So, okay, let us find from here first, then I will see what is happening in the figure. Let us find A bar intersection A bar complement as per our definition that we did, max or mean whatever. Okay. So, I find A bar intersection A bar complement. See, I have to take first element 2, and if it is intersection I will take minimum value. No, minimum of 0 and 1 is 0. Okay. Come to 3, 3 minimum 0.5 because both are 0.5, 0.5, 4, 0, is it okay? 4, 0, yes, 5, 0.5, 6, 0 sure, 0. Okay. So, now intersection for this case is 2, 0, this is okay. Then 3.5, okay, this 4, 0, 5.5, 6, 0, that means it is not 5, it is not a null set. Okay, understood? So, this is not a null set if you want to find complement of a fuzzy set and take the intersection of fuzzy set and its complement. So, it is not, this is the contradiction for with respect to classical set theory. Okay. Now comes union A bar union A bar complement, or A union A complement, you know it should be X, universal set. Okay. Let us see what is happening by your definition. So, I have to, okay, I will try to write here. So, A bar union A bar complement. See, 2 I have to take maximum. So, 2, 1, 3.5, 4, 1, 5.5, 6, 1. Okay. Now, see 2, 1, 3.5, 4, 1, this point, that means 5.5, 6, 0, sorry 1. So, we are not getting all X. Okay. So, these are two very important actually operator, means whatever we are getting this union and intersection, and I wrote something there. What was the name? What were the name? Law of contradiction. So, in set theory also, classical set theory, we say that law of contradiction. So, law of contradiction, and another one, law of excluded middle. So, if I have crisp set and fuzzy set, so these two rules, here I will get A intersection A complement as phi, but here I am taking bar because fuzzy intersection A bar complement may not be phi. Okay, actually not phi anyway. So, A union A complement is X, here A bar union A bar complement may not be X. Okay. These two are important results. Okay. So, these are the difficulties actually when you come to the practical application problems. Okay. Suppose you want to solve differential equation, eigenvalue problems. Okay. So, there we will have the problems. That is why I told you already that it is not easy to invert a fuzzy matrix. Inversion of fuzzy matrix easy means till date it is not there. Okay. How to find the inverse of a fuzzy matrix? People are doing, but with some assumption and all. Okay. Sometime wrong also they are publishing. Okay.